This related rate problem is about changing area of a rectangle. So we have a rectangle, and then one of the sides is 15 centimeters. So this side is 15 centimeter as well. I didn't tell you what this size equals to. My question is, how fast is the area of the rectangle changing when the other side is 20 centimeters and increasing? This is very important. I put that in red at 2 centimeters per minute. So just picture this in your mind. I have a rectangle, so I can use this technology to sketch the same rectangle. So notice that the other side is 20 centimeters. So do you see that the other side? Imagine that that is 20 centimeters and then increasing at 2 centimeters per minute. So that means I am stretching the rectangle horizontally, right? So increasing at 2 centimeters per minute. So at this speed, I want you to tell me how fast is the area of this rectangle changing. So the rate of change of the area. All right, so let's cut this. What do we have to do first? First, we have to define the variable. So I am going to let x equals to the other side. All right, so the other side. And then what is the area of a rectangle? Oh, one more thing. X is changing with respect to what? X is changing with respect to time. So since I mentioned time, I'm going to let t equals to time. They use minute, right? So in minute. So one more sentence, x and the area, they are changing with respect to time. Changing with respect to time. T. Okay. And then what is the area of a rectangle? The area is equals to the length times width, right? So that will be 15 times x. So now repeat this one more time. The area and x are changing with respect to time t. So let's underline this with respect to time t. And here is the characteristic of a related rate problem. So when you take the derivative, this is the function is not a of x. So when you take the derivative, this is the derivative of a with respect to time, dA dt. Why? Because the area is changing with respect to time. So you are taking the derivative of the area with respect to time. And then 15x, the derivative is just a 15, right? So I know the derivative of x is equals to 1. It looks like the other side is just a 15, but x is changing with respect to time. So you have a dx dt. Right? So they are both changing with respect to time. That's why there is a dA dt and dx dt. This is what you have to do in related rate. So now what I want you to do is you can rewind the video, okay, or you can pause the video. Just pause the video, close your eyes, just take a couple seconds to absorb this. I want you to think about this. So close your eyes and then think. X and the area are changing with respect to time t. That's why there is a dA dt and dx dt. All right, so I need you to absorb this right now. So after the derivative is done, you have to plug in what is given. So what is given? So let's write the different using a different color. So what is given? So we know that the other side, so x is equals to 20 centimeters. And then what else? We have the rate of change. And then this dx dt is increasing at 2 centimeters per minute. So I want you to do this for me, plus 2 centimeters per minute. Then you might ask me, hey, positive 2 is a positive 2. You do not have to mention positive. The reason this is very important, if I say decreasing, what happens if I change the word from increasing to decreasing? Then you will have to use negative 2 for decreasing. So let's put this down. So use negative 2 for decreasing. I can change this to a different problem. So let's say put that on a quiz, change the increasing to a decreasing. Then instead of plugging negative 2 to dx, instead of plugging in positive 2 to dx dt, you will plug in negative 2 to dx dt. All right, so that makes sense, right? Okay. So back to the function. So we have dA dt, that is what we are trying to find. And then 15 is 15, and then dx dt is equals to 2. Do we need to use the 20? The answer is you don't need to, because after taking the derivative, the x is gone, so you don't need to use the 20. So what if we have a different function, and then after taking the derivative, the x still there? Then you have a place to plug in your 20. So this is a 15 times 2, that is equals to 30. When I ask people to do related rate problem, I always say that report the units to me. So that is a square centimeter, so cm square per minute. Is this positive or negative? This is positive 30, right? So that means the area is increasing. So the area is increasing at 30 square centimeters per minute. If that is a negative 2, you have a negative 30, then the area is decreasing. So the triangle is, the rectangle is shrinking. All right, so this is then the end of this problem. If you like the way I explain related rate problem, give me a like, share the video for me, click the subscribe button if you are new to the channel. Truly appreciate your help and support, and I will see you all in the next related rate problem. Stay tuned and signing out.